Hi students, in this tutorial we'll be discussing about an important machine element bearings. In coming up series I will be discussing the classification of bearing, and then after the design of journal bearing, the design of rolling element bearing, and then after the numerical problems and little objective questions. So you should look forward with the next episodes. We'll be discussing with all these points. Before we beginning the design process of bearings, this may be the first question in your mind. Why we are using bearings in industries or in machines? Why we are using bearings? It's a simple explanation. Suppose you are using a shaft. Normally we are using shaft to transfer power from one point to another point in such a way that one end will be connected with an electric motor, or that may be an engine, or whatever the machine that you require. You need to connect shaft with that rotating machine, and you need to convey that power with another point. Within this case we'll be connecting our shaft with a belt drive. As you are aware, when a drive will be connected on the opposite end of the shaft will be under different kind of loading. That is the loading due to the loads in that belt. That may be some bending load, there will be some torsional load, and all other kind of dynamic unpredictable loads will be on that shaft. And this shaft is right now almost like a cantilever beam, that one end is supported on electric motor, another end is completely free. And due to this condition there will be deflection within this shaft. Suppose this shaft is a 2 feet long one, and while you turn on the motor the shaft begins to rotate, as well as it will deflect about its axis. There will be a up and down movement of the shaft with respect to the axis. So due to this jerk movement, you can't continuously transfer power with good precision. So to avoid this kind of vibrations, jerking on shaft, we can use a support to avoid this dynamic loads on that shaft. So you can go for a welded support or maybe a static support in the case of beams and all other kind of platforms. But it is not possible with a rotating, moving shaft. So you need a continuously moving support to support this kind of shaft. For that purpose, we will be using bearings. So these are the bearings which support moving machine elements such as shaft. So this is the basic idea behind the bearing. So this is why we are using bearings in industries. So bearing is a machine element which supports another machine element, may be known as journal, and it permits a relative motion between the contact surfaces of members while carrying the load. So these are the two important points. The first one, it permits the relative motion between the machine element, and it also carries the load. So bearing will dealing with the two function. One, it will carry the load, and the second one, it will permit a relative motion. So that's the speciality of bearing. And we can discuss with the classification of bearing. And the bearings are broadly classified based on the direction of load. So this is the first kind of classification. And the first kind under direction of load is radial bearing. So look at the first picture. In this kind of bearing, the loading will be perpendicular to the axis of shaft. These red arrows shows the direction of the load, and you could see the load is directed perpendicular to the moving rotating shaft. So these kind of bearings are known as radial bearing. And the second kind of bearings are thrust bearing or axial bearing. In this kind of bearing, loading acts parallel to the axis of rotating shaft. And this is the third kind. In normal practice, in most of the application, we will be under radial as well as axial or thrust load. So this kind of bearing is actually under a resultant or the combination of radial and thrust load. So these kind of bearings are known as combined load bearing. So we will be having bearing with the radial load or thrust load, or sometimes both radial and thrust load. Then we move forward to next kind of classification. So this classification is based on the nature of contact. The first category under this classification is sliding contact bearing. As that name indicate, sliding takes place between the fixed and moving element of bearing. And this kind of bearing also known as plain bearing. So here we have two kind of element. The first kind is a shaft. So it's a moving element, and the second one is the bearing. It's fixed element. So the moving shaft will be supported by the fixed housing of the bearing through this kind of arrangement. Here's the better picture of the bearing, and we'll be having a moving shaft, and it also known as the journal, or the shaft within the bearing is what we call it the journal. And we'll be having a bearing cap, and between the bearing cavity and the shaft there will be a clearance, and through that clearance will be supplying oil, and this lubricant help to reduce the friction and build up the pressure. And this is what the components of the bearing: the journal, clearance, housing, and the bearing liner. These are the different kind of sliding contact bearing, or commonly known as the journal bearing. And you should note this thing: the sliding contact are commonly known as journal bearing. Hereafter, when I am using the journal bearing, that I mean sliding contact bearing. Okay, the journal bearings are again classified into different category as per the bearing housing, that is full journal bearing. So these kind of journal will be having a 360-degree support all around the rotating shaft. The second kind is a partial journal bearing, so the support is partial. And third kind is fitted journal bearing. The difference between the third kind and second kind is, for fitted journal bearing, the diameter of the shaft will be bigger than that of the diameter of the bearing. But in previous case, the diameter of shaft is smaller than that of the bearing. And the whole family of journal bearing again divided into different category based on the lubrication system that we are using with between the shaft and the fixed bearing. Here, the first type of journals are hydrodynamic bearing, and the second one is hydrostatic bearing. And in between we'll be having thin film lubrication and zero film lubrication. And I will explain how these kind of bearings are working and what is the difference between hydrodynamic bearing and hydrostatic bearing in coming up videos. So please look forward for that. And right now I'm simply showing you what are the different types of journal bearing. Here it comes the rolling contact bearing. And bolts or rollers is introduced between moving and fixed element, and it is also known as anti-friction bearings. And the difference between a journal bearing and a roller bearing is basically, in previous case we will be having the sliding movement between the rotating shaft and the fixed bearing. But in this case, we introduced balls or rollers, sometimes the spherical bow, in other case maybe a roller, in special cases maybe a tapered roller or the pin rolling element, or whatever the case, will be having a rolling movement between the inner ring and the outer ring. So these are the components of a rolling contact bearing. You'll be having an inner ring that will be connected with the shaft, and there will be an outer race, and between inner and outer we have a rolling element. So it will allow a relative movement between the shaft and the bearing. And the speciality of this kind of bearings as compared with the previous journal bearing, roller will produce a very less amount of friction. So due to this property, this bearing also known as anti-friction bearings. The main advantage of rolling contact bearing is it convert a sliding movement into rolling movement, and that resulting high reduction in coefficient of friction, and the coefficient of friction is about 0.0012 to 0.002. And while designing a rolling contact bearing, will be dealing with the fatigue, friction, heat, and what are the lubrication that one should use, and the kinematic issues, material properties, machining tolerance, and the assembly of bearing, and all these factors should consider while designing a rolling contact bearing. I think you almost get an idea how a rolling contact bearing works. Here we have the inner ring and the diameter of the inner ring, what we call the bore of that bearing. So within that inner ring, we'll be fixing the shaft, and inner ring can rotate along with the shaft, and the outer ring will be fixed, and the ball or rollers allow the relative movement between the inner ring and the outer ring. So these are the different types of rolling contact bearing mainly available in industry. The first kind is ball bearing. The rolling element will be a spherical ball. In ball bearing, we have deep groove ball bearing, filling notch ball bearing, angular contact ball bearing. In the second category, most of the bearings are roller bearing. Instead of spherical ball, you'll be having cylindrical, maybe a needle, or otherwise a tapered, and that kind of bearings are roller bearings. I will be showing you the examples of some ball bearing. So this is what the deep groove ball bearing. The deep groove ball bearing, the speciality has it has a limited number of balls and primarily designed to support radial load, that is the load perpendicular to axis of shaft, but it also supports some thrust load, and the thrust capacity is about 70% of radial load capacity. And it's another kind of node that is filling notch balls. The speciality of filling notch balls bearing have the same basic radial construction as the previous, but the filling notch permit more balls to be used, so it has high capacity than deep groove ball bearings. And it's another kind of ball bearing is angular contact ball bearing. You could see it have an angular contact with the ball, and use by using that angular contact it can also support a better amount of thrust force along with the axial force. And this is the difference between a normal deep groove ball bearing and angular contact bearing. You can see that angular contact with the outer race and the ball. And these are some other standard bearings: deep groove, filling notch, angular contact, shielded. And this is what the self-aligned kind of ball bearing will be having a special geometry here. The speciality of self-aligned bearing is it could accommodate a little deflection in the shaft by using this geometry. So if there is a minute deflection in the shaft, you can use self-aligned bearing. It have a capacity to align itself, and it's the story in nutshell. Bearings are classified into two. The first category, sliding contact bearing or journal bearings, and the second category is rolling contact bearings. And within sliding contact bearing, we have hydrodynamic bearings, then hydrostatic bearings, then thin film lubrication, and then after the zero film lubrication. And under rolling contact bearing, the ball bearing falls under rolling contact bearing, and cylindrical roller bearings, and finally the needle bearings. It is the total classification of bearing or the family of bearing. And see you in next video.